All right, let's take a look at another CSES math problem, which is actually the last CSES math problem. So congratulations, you made it through everything once you make it through this video. So what's going on here? So stair game, so it's another game. We have n stairs, and each stair has some number of balls. There's 2 players who move, alternating. And you get to pick a stair, and you can move any number of balls sort of down one stair, right? And you can't pick the first stair, because there's no stair below it. And so you win if you move like all of the balls down to the first stair, right? So, the balls are moving down one step at a time. You can move as many as you want from a given stair, and you win. You win once they all make it all the way down. So this is sort of reminiscent of NIM, right? This would be NIM if all of the balls, move directly to the first stair, but instead they're moving down just one stair. And so the stairs are sort of related in a somewhat maybe confusing way. And so they just give you a bunch of, sort of positions, and you need to figure out who wins first or second, right? As usual, the same as the other game problems. So how do we do this? So the first thing to note is that the first stair, they actually give you how many balls are in the first stair, but it doesn't matter at all, right? All those balls are already dead. They can never move. And so that doesn't matter. So that's easy to see. The thing which is not so easy to see is that the third stair also doesn't matter. And the reason is, if you move any balls from the third stair to the second stair, I can just move the same number of balls from the second stair to the first stair, and then we're back at the same position, and it's your turn again, except there's less balls on the third stair. So I can cancel out all of those, any move that you make on the third stair, by just doing the same move. You move them from 3 to 2, and I move them from 2 to 1, right? And now they're dead. So the balls on the third stair actually don't matter, because of this canceling out thing, right? They never help you win, because the other player can just ignore them by just moving them to the first stair. So we have the balls on the first stair and the third stair don't matter. And so maybe it won't surprise you to learn that the balls on the fifth stair also don't matter, because of the same canceling thing, right? If you move any number of balls from the fifth stair to the fourth stair, I can move them from the fourth stair to the third stair. And we said the balls on the third stair don't matter. So actually, in general, all of the odd-numbered stairs don't matter, right? All those balls are effectively dead, because of this sort of canceling out thing. And so now we're actually back to NIM, because the even balls on the even stairs, well, you don't move them to stair number 1, you move them to k-1. But actually, as soon as you move from, any ball that you move from an even stair moves to an odd stair. And we said that all balls on odd stairs are dead, they don't matter. So basically, you're playing NIM on the even stairs, because when you remove balls from even stairs, they're effectively dead. Right, so a game of this stair, the stair game is equivalent to a game of NIM, where you just cancel out any moves from odd stairs, and any moves from even stairs are moves in the NIM game. So the solution is that we XOR together all of the even stair sizes, and if that's right, so now it's just NIM on the even stair sizes, or the even stair sizes. And so we apply the solution for NIM that we learned in the video, 2 videos ago, which is we XOR together all those numbers, and if that's 0, then the second player wins, and otherwise the first player wins. Right. So here we just have 2, the XOR of 2, just 2. So the first player wins, that's not 0. Here we have 1 and 1, XOR together with 0, so the second player wins, and here we have 3, XOR to 3, so the first player wins. So let's put it up. So there's an indexing issue, right? The first stair has I equals 0, so only the ones where I is odd count. those are the even number of stairs. It's a bit confusing. So if that's 0, the second player wins, otherwise the first player wins. Includes. All right. First, second, first. Okay. So that's the end of the math section. Cool. Right, so it turns out to just be another game of NIM, but only on like half the numbers. And so we had to think about it to realize that the odd numbered stairs, starting from stair 1, didn't matter though. It was obvious that stair 1 didn't matter, but it requires some insight to realize that stairs 3, 5, 7, and so on don't matter. And then a little bit more insight to see that it's now a game of NIM on the even numbered stairs. That's the problem, and that's the math section. Awesome.